Okay, second half of this is logarithmic graphs. The only difference, it's like, do you guys remember doing inverse functions where you like switched the x and y?
No.
Very beginning of the year. Very beginning of the year. This is exactly what, so exponential and logarithmics are inverses of each other. They switch. The x's and y's switch. So some fun facts that we are gonna get more into as the unit progresses, but some prior knowledge of things that I want to tell you as we go into this, and we'll learn the why in this next part of the chapter. But I'm just gonna show you what you need to know for right now. So if you have like log 2 of x, it is like, and like let's say that I use this 1/8 right here. If I were switching it to be an exponential, then it would be 2 to the 1/8. Wait, hold on. It would be like saying 2 to what value? So 2 to what value? Like f of x, whatever f of x is going to be, gets me to 1/8. So basically, in your mind, you have to think, how do I get from, like, what power do I need to raise 2 to get to 1/8? Negative 3. What do I need to raise 2 to get to 1/4? Negative 2. What do I need to raise 2 to get to 1/2?
Wait, what?
0. 1.
Wait, why? Oh.
2. 3. Perfect. Yes. Okay. Now if I want to graph this, I probably should have expanded this a little bit more. I'm gonna just exit. There we go. Now if I want to graph this, then I'm going to plot my points. So I had negative 3, negative 2, negative 1, 0, 1, 2, 3. When you have the fractions as x values, it starts kind of looking like a what kind of line?
A solid line.
Like a vertical line, maybe?
A vertical line.
There we go. 2, 1, 4, 2, 8, 3. So it looks something kind of like this. Now in the last part of the section, we had horizontal asymptotes. What is a wild guess of what we would have here? Vertical asymptotes. So what is the equation of this line? It's not a y equals, but x equals.
What equals 0?
The domain. And so in the last part of the section, the domain was always all real. Now the range will always be negative infinity to positive infinity. And my domain will be what to what?
Domain would be 0.
My mind is actually.
So it switches.
Oh.
Yeah, it's just the opposite. Is it to the right? Is it increasing or decreasing? Increasing.
Yes. Yes.
I'm going to skip the second one. And then as x is going to positive infinity, so the stuff that's below here, as x is going to positive infinity, my y is doing what? Positive. As x is going to 0, so as x is going to 0, negative infinity.
So it's just like the range again.
Right. I'm going to skip this one just for time's sake. So logarithmic functions are inverses of exponential, which is what we just did. When I said in the last part how you set your exponent equal to 0 and 1, the two things that you'll look for now is you're going to look at what is inside the parentheses. So we'll get to some examples and I'll show you what that means. So you want to set the stuff in parentheses equal to 1 and equal to whatever your base is. So this right here is called your base, where it's always going to be positive and it's never going to be 1. So write this down so that you have it, but it really will not make as much sense until we do an example. So, does everyone have this written down? Good. Okay, transformations are exactly the same. So we have your A is your vertical stretch or compression. If it is negative, then we say that it reflects the what? Good. The H tells me what? Left or right. This also, H is going to be my vertical asymptote. So X equals H. So now we're looking at our inside parentheses for the asymptote. And then my K tells me up or down. And then my B still tells me horizontal stretch or compression. So same stuff. But the only difference from last unit to this unit is now the asymptote goes with the H instead of the K. Okay, we're gonna skip number 3. So let's look at number 4.
He probably is.
Let's look at number 4. So my first step when I'm doing my 2 points is I look at this stuff in parentheses. I want to set it equal to 1. And I want to set it equal to now my base, which is 3.
Is it always equal to 1?
Equal to 1, yes. 1 stays the same and then base. So equal to 1 and equal to base. When it equals 1, the log of 1 is always 0. So when I put in log 3 of 1 minus 4, it's like saying 0 minus 4. It's negative 4. And why is that? Like, why is log of 1 0? It's like raising anything to the 0 power equals 1. It's just the opposite. So this right here, if I have log base 3 of 1 equals 0, that is like saying, like, to get from 3 to 1, I have to raise it to the 0 power. These two mean the same thing. It's just the inverse. But they mean the same thing. So that's why the log of, anytime you have a log of 1, it's always 0. Because it's like raising anything to the 0 power equals 1. Okay, so I have an ordered pair at 1, negative 4. The second thing that I plug in, guys, stay with me, we're almost done. When I plug in x equals 3, log base 3 of 3 cancels out and just becomes 1. 1 minus 4 is negative 3. Because it's like saying 3 to the first power equals 3. So that's why it becomes 1.
Any numbers that's thrown in there is equal to 1, except when 1 is equal to 0.
Log of 1 is equal to 0.
And then every other
Log of base is equal to 1.
Yeah.
So my two ordered pairs that I have are 1, negative 4 and 3, negative 3. Now, do I have a vertical asymptote?
Yes.
No,
No.
because it's
Oh, yeah.
inside the parentheses. There's nothing inside the parentheses, so it is x equals 0.
No parentheses, no asymptote.
Right.
Thanks, Zoe.
Domain 0 to positive infinity. Range is always now going to be all real. To the right, is it increasing or decreasing? Increasing. As x is going to positive infinity, what is y doing? Positive infinity. As x is going to 0, y is going to negative infinity. And what are my transformations? This 3 tells me what? Not vertical. Horizontal stretch. And then what does the minus 4 tell me?
Down 4.
Down 4. Okay, try number 5 and then we'll be done. So the two x values that I chose, I wanted to set this stuff in parentheses equal to what two numbers?
1 in base. 3 and 1.
1 and equal to base, which is 3. So the x values that I chose were 2, because x minus 1 equals 1, move the 1 over 2, and x minus 1 equals 3, 4. Now, when I have log of 1, that just becomes 0. So 0 plus 2 gives me 2. When I have log of 3, it becomes 1. 1 plus 2 is 3. So that's how I got the 2 and the 3. Plot the points. I have a vertical asymptote at 1. Domain is 1 to infinity. Range is negative infinity to infinity. It is increasing. So it says 0 and 0. What I want us to do is cross this out and change it to, so as x is approaching infinity, what is my y doing? Infinity. And as x approach, where does it stop? What x value does it stop at?
1.
Negative, no, positive 1. Negative infinity. My transformations, what does it do?
Right.
Horizontal stretch by 3.
Students, at this time, if we could have you line the first floor hallway so we can recognize our...
Okay, if you want to try the rest of these notes, they are on Canvas. And then homework will, I think there's 12 problems or 12 graphs.